Yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
It's still visible.
Right. So in the yesterday demo session, just I was briefing you about Spark, PySpark, need for PySpark. Just we have a quick review what we were discussed yesterday, right? So Spark is a open source distributed execution framework with in-memory computing feature and in parallel process style. In parallel process style used for large scale data processing, right? And Spark is a general engine for big data analysis, right? It's for big data analysis for processing and computation, right? And why PySpark? It's a Python API to use Spark, right? It's a Python API to use Spark. PySpark is a lightning fast technology. So PySpark is a open source cluster computing system, right? Which is used for big data solution. And it's a lightning fast technology that is designed for fast computation. PySpark is used for running distributed SQL, creating data pipeline. So Spark is a data flow language. The output of one will be the input to the next flow, right? So ingesting data into the database and running machine learning algorithms and working with graphs or data streams. Here we say micro batching. So this Spark is Hadoop Spark is meant for batch processing. Batch processing, right? Batch processing means user interactiveness is not required. Online processing means user compulsory should give the input, right? But for batch processing, user interface is nowhere required, right? For example, like a million credit card statements for millions of customers, generating credit card bills for millions of customers. That is monthly statement generation, phone bill for millions of customers, right? So here user interference is nowhere required, right? So those kind of batch applications we go for this, for batch processing or for batch applications, right? And for micro batch, we go for data streams like Spark streaming is used for that micro batching, right? I want quick updates for every 5 seconds. I want updates for every 10 seconds. I want updates. For that, we say micro batching. Windowing, we have got a concept called windowing. At one side, the events keeps on generating at a rapid speed. The events will be generating. We need to have such a processing, such a very high speed processing technology to process the events that are generated within the same speed, right? So the rate of speed the events are generated at the same speed the events has to be processed. So at one side events are generating, at the other side the events are processed by using Spark, PySpark, right? So very high speed processing and need for PySpark. So working with Grow for data, need for PySpark. So if you see like a huge amount of data is getting generated online and through offline, right? So where this data, whatever data we are getting, right, they consist of hidden patterns, market trends, unknown corrections, right? Customer preferences, all this, right? Okay. So we require some more efficient tools for performing different types of operations on this huge data or big data. So already we have got many tools, but the tools are not that much appealing. So we need to have a flexible tool which we can crack the big data for gain benefit from it. So PySpark is such a kind. So combination of Python and Spark. PySpark is nothing. PySpark. What is PySpark? Nothing but Python plus Spark. Spark is an execution model implemented by using Python language. Python API for Apache. So combining both Python and Spark would be the most efficient way for the world of big data. So that's why Apache. So all these are Apache products. So the Apache Spark community came up with a tool called PySpark. This Python API for Apache Spark. So we have seen differences. People currently Spark implemented using Python and Scala. Both are equally used in the industry currently. So though both has got advantages among each other, right? So Python is interpreted and dynamic typed. No need to define the types based upon what value you are assigning. that variable gets created automatically. If you're assigning integer value, integer variable X is created. If you're assigning a float value, float variable Y is created. Python is open source and has a huge community. Scala community is smaller than Python. Python has got powerful libraries. Scala has got less libraries as compared with Python, like thousands of modules Python provides for different environments, but Python is slower than Scala because Python is interpreted. Scala is faster than Python. PySpark features. In-memory computation means storing and storing of data and processing the update. Everything happens within the memory level, RAM level. That's why in-memory computation, that's why very high speed we see in Spark as compared with the other technologies, right? Yes. Lazy evaluated means whenever action is performed, then only the data flow executes. If you won't perform any action, then the data flow won't execute. Lazy evaluated, whenever required, only you will perform action. Wherever required, you will perform action. Like lazy evaluated. Okay. Powerful fault tolerant model. Powerful fault tolerant model means fault tolerance means as the data is distributed across multiple worker nodes and are processed parallelly during this processing. If any one machine goes down, then there is a data loss. So the PySpark has the capability of recomputing the lost partitions that I'll be discussing in brief in the fault tolerant model. Immutability, the original data remains same. But if you want to perform any transformations, filterings, groupings on the data, you can perform, but a new data will be created, but the old data remains unchanged. Immutability means changes, modifications, right? Not allowed to the original data. Partitioning means your data is going to be get partitioned. Then only that partitions can be stored across multiple RAMs of multiple worker nodes and can be processed parallelly. Persistence means, yes, yesterday I was just briefing about persistence. Persistence means if you persistence, if you persisted a particular partition, then that partition will remain in the RAM. It won't go away from the RAM. It whenever which one you will persist means the one whose flow is used by multiple flows, whose output is used by multiple flows, that one will persist so that it can give output to the multiple flows. It won't be removed from the RAM. So in brief, I'll be discussing with multiple examples, right? Persistence, we have got a lot of discussion on this persistence, which is the important feature of this PySpark. Persistence is one, in-memory computation is one, are the two important features of this PySpark, where you won't see another, like even in Hadoop also, it's not, you won't see this this in-memory computation and persistence in Hadoop. You cannot use the already executed transformation. We cannot reuse the already executed transformation. In Spark, we can reuse already executed transformation, but in Hadoop, every time we need to go from the starting first step one onwards to the last. But here already, if it is executed, we can reuse its output and go with it. No need to restart or re-execute from the beginning. So I'll be giving with multiple examples when we discuss persistence, different ways of persistence, option persistence, different persistence options, lot of discussion. Parallel processing. So here the data as it is divided into partitions, distributed across multiple RAMs of multiple worker nodes and are processed parallelly, where you can achieve more speed, very high speed, right? Yes. Real life usage of PySpark, right? Yes. So where exactly this PySpark is used mostly? So I said in the commercial sector, it is mostly used in the financial systems where this batch processing is mostly preferred in the financial fields or financial sectors like banks and other financial fields where which uses Spark to retrieve the customers. See, for it to provide a loan. So the Spark retrieves the customer's social media profile and analyze to gain useful insights, which can help them in taking the right decisions. The extracted information, it can be used for different purposes, for targeted ads, for credit risk assessments, right? And for clusterings, right? For customer segmentations. So even Spark plays a vital role in fraud detection, right? So in real-time processing, here Spark can perform real-time processing. What do you mean by real-time processing? See, batch processing and real-time, both it can perform. Spark means, what do you mean by batch processing? Means if today if some 1 lakh transactions happened, at the end of the day, you are identifying that some 20 fraud transactions has happened. But real-time processing means whenever the fraud transaction happened, then and there only identifying that a fraud has happened, fraud transaction. That is real-time processing. And batch processing means at the end of that, you are just going to know that some fraud transactions has happened. Secondly, in healthcare, see, Spark is mostly used even in the healthcare, right? So it is used to analyze the patient's records along with the previous medical reports and to identify which patients is mostly probable to face the health issue, right? So predicting, right? Predicting who is going to face that issue and which patient is mostly going to face this kind of problems, right? Predictions. And the entertainment industry, right? As I said, today everything is moving towards this online streaming, right? The popular online streaming like Netflix, it's using Apache Spark for real-time processing, right? For online movies, web series, and to its customers. Where this Netflix, I was saying yesterday, 450 billion events per day, they are streamed over server-side applications. Trade and e-commerce also, right? Even that famous e-commerce sites like Flipkart, Amazon, all this they use PYSPARK for this advertising, right? Means this they are going to provide, they offer some enhanced customer experience and optimizes the overall performance. Even for the tourism industry also, it's widely used to provide advices to millions of travelers by comparing hundreds of tourism websites. So even you may ask, you might be asking some queries. Okay. You may ask, already we have got Apache Hive. Apache Hive is there, right? Apache Hive, then again, necessity for this Spark SQL, right? We have got a component called Spark SQL. Hive is good, performs very good in all the things, but Hive doesn't support two things. One is updation, it cannot support. Delete operation, update and delete, it's both are not supported. Remaining everything, Hive is fine. Hive has got even people, there have got many jobs only on Hive, Apache Hive, right? Where it's a database data warehouse kind of environment, right? In this big data environment where it does, but Hive doesn't support two things. Updating cannot be done, deletion operations, update and deletions. And also here in Hive, MapReduce execution is going to happen. MapReduce, it was talk of the industry, right? And if you talk in 2012, 13, 14, 15, 16, right? MapReduce was a hype in the industry. That is Hadoop MapReduce, right? But MapReduce has got outdated because of its huge codings, which was unable to attract the customers, programmers or developers, right? So after MapReduce, we have got components like Apache Pig, Apache Hive, right? Hive was doing good. Hive is a kind of an environment, right? where very less coding required. We've got, I mean, you can create many UDF, UDTFs, right? But it cannot support. But one more Hive internally this map reduce execution is going to happen. But we can also integrate Spark and Hive so that Spark execution model going to happen, right? Instead of map reduce execution model, you can execute Hive queries, Hive HQL queries with using Spark execution model. Spark is a very high speed processing and in-memory computation. That is the major advantage we see. Okay, so if I come to this, okay, coming to the basics, right? Yes. You need to know something about this evolution of Spark. Evolution of Spark. Spark was developed by Vijay Sunder. It was developed by Vijay Sunder in AMP lab, Berkeley. In the year 2009, Spark was introduced in the year 2009, but it was open sourced. It was open sourced in the year 2010. It was open sourced in the year 2010. It was donated to Apache Software Foundation. It was donated to Apache Software Foundation in the year 2013. In the year 2013. Just 1 second. Give me a second. It was introduced in the year 2009. It was open sourced in the year 2010. It was donated. It was donated to Apache Software Foundation in the year 2013. So I was already discussed about the features of PySpark, right? Yes. Okay. Spark. Spark can run on Hadoop Yarn cluster. Spark can run on Hadoop Yarn cluster, right? AWS. Spark can run on Hadoop Yarn cluster. It can run on AWS. See what are the Spark can run on the distributed clusters, right? Hadoop Yarn, AWS, and Mesos. Distributed clusters. Spark can be coded with Spark can be coded with Scala programming, right? It can be coded Scala. It can be coded with Python. Spark can be coded with Scala. Spark can be coded with Python, and Spark can also be coded with other. Spark supports multi-language support like Scala, Python, Java, and R language. Spark can be coded with Scala, Python, Java, and odd language. Hadoop execution generations. If you talk about the Hadoop execution generations, right? You know about like a map reduce. So it was king in the market for especially from 2010 to 2017-18. It was a hot cake in the market, but it got outdated because of huge codings, right? And secondly, we have got like Stage, and third, Spark. MapReduce, Stage, and Spark. So this Stage and Spark. So if you see both comparing within the Stage and Spark. So Stage and Spark, right? Both follows DAG model, directed acyclic graph model. Both follows directed acyclic graph model, but Spark.
It is directed DAG means
Directed acyclic graph model. Directed acyclic graph model. There won't be any, see, I said it's a data flow, right? There won't be any closed loops. Directed acyclic graph model. But the stage is not in memory computing. Stage is not in memory computing. Spark is in memory computing. It has got very high speed as compared with Stage. But if you see what are the other, not only Spark, do you have any other in-memory computing systems in the market? Okay. Other in-memory computing systems, other in-memory computing systems. Other in-memory computing system means we have got like SAP HANA. SAP HANA is in-memory computed. So if you say HANA and Spark, if you compare HANA and Spark, right? HANA and Spark, both are in memory. Both are in-memory computing systems. Both are in-memory computing systems, right? But HANA is not distributed. HANA is not distributed.
sorry, can you please elaborate what is distributed? I mean, the data will be
Yes,
processed.
HANA is not distributed, but Spark is distributed RAM. But Spark is distributed RAM. For example, if I got 10 systems, for example, if I got some 10 systems, each system of 16 GB RAM, total RAM capacity. If I got a cluster within this, I got like first assume that 10 systems, each one having 16 GB RAM. Total RAM capacity 160.
160.
If 100 systems, each system with 64 GB RAMs, 64 GB into 100, 6,400, right? 6,400 means distributed RAMs. But in the case of assume, but for example, so what happens here in the case of Spark, if we want to keep on increasing the cluster, we can't keep on incrementing that. What is that? Commissioning and decommissioning, we say, right? We can keep on adding the systems, depending upon the incoming data. For example, if 10 TB, for example, if you got like 10 DB, memory, 10 dB memory allocated for HANA. Daily 1 TB comes. Assume that daily 1 TB data is coming. Daily 1 TB. Daily 1 TB is coming, right? So it can store only 10 days data. It can store only 10 days data. To store the 11th day data, right? The first day data has to be removed. To store the 12th day data, the second day data has to be removed, right? So we cannot increase this. But in the case of Spark, distributed, right? It's distributed RAM. So if we keep on increasing that capacity, right? So Spark is distributed means we have got the Spark data objects is subdivided into partitions. What is a Spark data objects are subdivided into partitions. These partitions are distributed. These partitions are distributed across RAMs of different worker nodes, right?
It's kind of auto scaling.
Yes, yes. So here the advantage is huge data sets also can be loaded into in-memory RAM. So motivation towards Spark, in-memory computation, distributed executions, right? So observe here. For huge storage, we go for Hadoop HDFS. Because Hadoopian, everything goes on Hadoopian, right? And for fast processing, we go for Spark. For huge storage, Hadoop HDFS, and for fast processing, Spark. Combinedly both can store and process. So combinedly both can store and process, right? That's why. Previously, we have got SAN, right? Storage area networks, SAN for unlimited. So it can store unlimited data, but they cannot process the data, right? Yes. Storage area networks, right? So Spark is mainly designed for batch applications, user non-interactive applications, iterative algorithms. Most of the machine learning algorithms are iterative in nature. Iterative algorithms. Interactive queries. Streaming. So these things you can perform streaming also using Spark, micro batching, I said, my batch applications, iterative algorithms, interactive queries like you have got Spark SQL, right? Using that we can. Okay, it supports advanced analytics. It supports what? Advanced analytics like graph algorithms, machine learning algorithms, streaming, SQL queries, right? Hadoop processing. So is the question. No, it's not available in Udemy. No. So observe, right? Hadoop, if most Hadoop and Spark, Hadoop and Spark, right? Most of them has got what is that Hadoop and Spark. Drawbacks of Hadoops, right? You can see everything advantages in Spark. First thing is transformations cannot be reused. Transformations, Hadoop drawbacks. Hadoop MR map reduced. Drawbacks, right? Hadoop MR drawbacks. Transformations cannot be reused. Bad for iterative algorithms. Bad for iterative transformations can be used. Bad for iterative algorithms. Not a flexible parallel process. What is this? Not a flexible parallel process. And for like slow processing, right? Yes. Transformations cannot be reused. Bad for iterative algorithms. Not a flexible parallel processing. Slow processing. Okay. Transformations cannot be reused means, for example, you want to perform, for example, if you want to multiple aggregation, sum aggregation, average aggregation, max aggregation, min aggregation. For example, you got some employees. I want the total salaries of all the employees. I want the average salaries, max salaries. What is the max salary given, min salary given? This kind of aggregations. So first, we need to extract, okay, we need to extract, right? For all this, I want department number wise, department number wise, what are the department 11, department 12, department 13. So 3 departments are there: marketing department, HR department, finance department. Department wise, I want what is the total salaries given, what are the average salaries given, what is the max salary given, min salaries given. So the first task, you need to extract the department number and salaries from the employees data, employee ID, employee name, salary, designation, department, city. Many fields are there. First thing is you need to extract. So there is a process to extract the department number and salary from all the lakhs of records. After that, so you perform. After that, you perform this aggregation, sum or max or min. But for every operation, you need to again separately extract the department number and salary. Again, for third max also, I need to extract department number and salary and perform. And for min also, I need to extract. But once you department number salary is extracted, you cannot perform some max min like that. So in the case of here Hadoop, first extract, perform, but not like that. Already you extracted. Can I reuse for the next operation? Means no, you cannot reuse that. Again, everything map reduce. See that word, map reduce. First mapper and reducer, both has to be executed. Mapper will extract the department number and salary, and reducer performs the aggregation. But without running mapper, reducer cannot be executed. So compulsory for every task, mapper should be initiated, next reducer. But without running mapper, directly reducer can't be executed. That is the drawback. Compulsory map reduce. For every task, again, mapper should be executed again. Even though the task is already done, the transformation directly mapper output can't be used by the reducer and perform it. No, you need to initiate, execute it, right? Yes. Okay. And bad for iterative algorithms. Most of the uh, data analytics, most of the algorithms are iterative. Iterative means you keep on applying that algorithm, you will get some error. Again, apply, again you will get some error. You keep on applying until the error becomes zero. Not a flexible parallel process. Not a flexible parallel process means without executing mapper phase. Directly, can you execute mapper and map reduce? Here in Hadoop map reduce, mapper and reducer, two phases are there. Will the two phases execute parallelly? Mapper phase is there, partitioner phase is there, and reducer phase. Three phases are there in Hadoop. Those three phases won't execute parallelly. First mapper should execute, it output should be given to reducer, then only reducer executes. But both mapper reducer can't be executed parallelly. But Hadoop is meant for parallel processing. But here mapper and reducer, they're not executing parallelly, right? Sequentially, one after the mapper output given to reducer, reducer takes that output and executes. Slow processing, not a flexible parallel processor. That's what I discussed. Slow processing, right? Hadoop processing as compared with Spark processing, right? Spark is very high speed. So for example, for the slow processing, Spark sorted, observe this, Spark sorted, this example, motivation towards Spark, you can say, right? Spark sorted 100 TB data, 100 TB of data using 206 nodes, using 206 nodes, right? In 23 minutes. Sorry. So Spark sorted 100 TB of data using 206 nodes systems or CPUs, right? In 23 minutes, it has taken 23 minutes. Previous, if you see that previous world record, was set by Hadoop MR cluster. Hadoop MR cluster. Previous world record was set by Hadoop MR cluster, taking 72 minutes. In 72 minutes. In 72 minutes, taking the two. It has taken how many nodes, you see? 2100 nodes. Even by taking the 2100 nodes, still is unable to reach that Spark speed, right? Spark just only using 206 nodes. So motivation, this is what motivation towards Spark. So without any knowledge of this, without knowledge of Hadoop also, people can understand Spark. Spark has got a great demand, great boom, right? You can just check. You can just check in the Google, PySpark jobs, lot of jobs I was saying, right? Even the package will be high as compared with other technologies. Yeah, that's why I was saying you need to have technical skills, even if we are just trying for bigger packages, even the same way, they'll be checking your skills, technical skills in which in this PySpark, right? So motivation towards PySpark. So for example, Spark 100 times faster. Spark 100 times faster than MR. Spark 100 times faster than MR. In memory. Spark 100 times faster than Hadoop MR. Spark 10 times faster than Spark 100 times faster than Hadoop MR in memory. Spark 100 times faster than Hadoop MR in disk. Okay. So that is what advantages of Spark over advantages, Spark advantages. Transformations can be reused. Good for iterative algorithms. Flexible parallel process. So here flexible parallel process, we can control the parallel processing in Spark, but in Hadoop parallel processing can't be controlled. You cannot increase the parallel processing further, but in Spark, we can increase the parallel processing further, right? Transformations can be reused. Transformations can be reused means yes. I'll show you some example of this transformations can be reused. Observe this, transformations can be reused means this is the data. Spark data. And that you perform some kind of transformations like transforming or filtering. The output is you get a D2. And that if you perform any operations, merging, grouping, aggregations, transformation, filtering, right? And then D3 is created. From D3, same D3 output you take D4, D5. Same D3 output you take D6, D7. SDI is saved, right? So this takes some Spark data is, and here D8, D9. But if you observe, 3 flows are there here. Yesterday I was saying that this flow 1, flow 1, flow 1, flow 2, and flow 3. flow 1, flow 2, and flow 3. 3 flows. The 3 flows, if you observe, the first 3 steps are common. First 3 steps are common. Assume you executed flow 1. Flow 1 you executed. Again, flow 2, D1, D2, D3, D6, D7, D1, D2, D3, D8, D9. If you persist this D3, means make it permanently available within the RAM. Make this D3 permanently available in the RAM. If you make it permanently available, when the flow 1 is executed, right? Flow 1 is what? D1. D1, all its partitions will be loaded into multiple RAMs. They'll be processed, the output will be given. The output is nothing but D2. Again, D2 partitions are stored across multiple RAMs, and the output is processed D3, D4, D5. This is flow 1. D1, D2, D3, D4, D5. Flow 1. This much data cannot be fit into the RAM. D1 is already a huge data. D1 data is huge data. I think it is 1 TB. But this much D1, D2, D3, D5, D4 all cannot be stored within the RAM. D1 data will be stored. When D2 is ready, when D2 is taken, the output of D1 output is taken as input by D2. Once it is taken, it's processed. D2 gets removed from the RAM. Now only D2 is stored in the RAM. Only D2 is available in the RAM. Only D2 available in the RAM. When D3 is ready, D2 gets removed. When D4 is ready and computed, D3 gets removed. When D4, D5 is ready and computed, D5, once the total output is collected, then D5 also. Now what is present? Nothing is present in the RAM. So flow 2 again, if we execute, right? Again, 1 by 1. We should execute from the starting. But if D3 is persisted, right? Directly flow 2 can't be executed from the starting. Directly D3 output directly taken by D6, D7 means here transformation is reused, right? Already D3 transformation is executed in the first flow. Again, here we no need to execute directly. I can take its output. So flow 2 decreased, right? In flow 3 also the same. Flow 3 also directly we can start from D3 as it is available in the RAM to give output to the next flow, D8 and D9. D3, D8 and D9. Okay. So understood, right? For example, D1, D2, D3, D50, from D50, D70, D90, D100. 3 flows are there. First flow, second flow, third flow. Once the first flow is executed, assume, and D50 flow is used by D50 output is used by multiple flows, then persist it. Means whenever the next one is ready, don't remove this D50. Means whenever the second flow, whenever you are executing second flow, from where you will be starting? Second flow starts from where? Yes. Whenever you persist from D50 onwards, right? No need to execute the first 50 steps, right? 50 steps decreased means transformation of D50 is reused and directly D90. 2 steps, 50 steps decreased from D1 to D50. And third flow also can reuse it, but first flow has to be executed. Without executing the first flow, First flow executed means D50 1 by 1, D1, D2, D3, D5, D70, X. Third flow directly D50 to D100. Right? Okay. So that is what transformations can be reused. Transformations can be reused. That is the major advantage in Spark, right? That persistence feature is there and in-memory computation feature is there. In memory, because of this in-memory computation is 100 times faster than Hadoop. See what happens if there is no enough D50 and D90 means all that. See here, D50 is available, D50 is available, D90 is also available. So depending upon the incoming data, we are going to increase, we can scale, we can increase the cluster capacity, right? We can increase the cluster capacity, commissioning and decommissioning, we say, increasing the cluster capacity, increasing the systems, worker nodes can be increased and decrease it. But we are not, see, if you have got a good cluster capacity, if you have got good RAM, see, if unable to fit in the RAM, we will make it to fit into disk. If RAM capacity is not there, persistence options are there. If unable to persist within the RAM, they can be stored within the disk. Yes. If unable to fit that much of RAM capacity is unable to maintain, and if it's unable to store, then we can also persist within the disk level. Disk memory can be used. So there is the option memory only, disk only, memory and disk. In this way, which option you want? Memory and disk means if memory not sufficient, disk can be used, right? Yes. And yes, that is what the advantages of Spark over Hadoop MR. Hadoop is also Hadoop already, it's a very fast processing model, right? And good for iterative algorithms. Spark mostly used for iterative algorithms, right? Machine learning algorithms. Flexible parallel process. We can increase the parallel processing furthermore, right? We can control the parallel processing in the case of Spark. And there was a component, if you see in Hadoop, it is also very less coding we see, and we see like Apache Pig versus Spark. Spark Pig also there has a great boom. It had a great boom, right? It was with very less coding, like nearly 100 lines of Java code. You can write within 5 to 6 lines in Pig language, right? So it was mostly used. Apache Pig and both commonalities, both are data flow languages. Both are data flow languages. One output is the input to the next flow. Pig entire data flow converted to one MR job, one map reduce job. Again, map reduce has drawbacks. But bigger backend map reduce execution, again map reduce has drawbacks. And again, MapReduce has got drawbacks, right? Yes, both are data for languages only, but Spark is in memory, Pig is not in memory computing. There was a talk, if you see in 2017-18, there was a talk, right, when Spark was in the boom. Spark, there was a technology called Flink. There's a technology called Flink, right? So which dominated Spark. Even there was a talk that Flink dominating Spark, and Spark will be away from the market. Spark is going to vanish from the market as Flink is dominating it. Yes, it was true, but both are from Apache family. Both are from Apache family, right? Both purpose. Both purpose. Both purpose and objective is same. In the initial versions. In the initial versions of Spark. In the initial versions of Spark, right? In the initial versions of Spark, it was weaker in terms of machine learning. It was weaker in terms of machine learning. But the heart of data analytics. But the heart of data analytics is machine learning. But from Spark 1.6 onwards, but heart of data analytics is, but from Spark 1.6 onwards, Spark has introduced powerful libraries. It has introduced powerful libraries for ML and for machine learning, and it has got powerful libraries for machine learning and graph algorithms. From Spark 2.0 onwards, from Spark 2.0 onwards, Spark has dominated Flink. Before 1.6 version. Before 1.6 version, Spark less than Flink. Before Spark, before 1.6%, Spark less than Flink. After 1.6%, Spark equal to Flink. After 2.0 version, right, Spark dominated Flink. So now we cannot hear the word Flink now, right? So this is what Spark comparison with other technologies, right? Spark advantages, right? And Spark features. So mainly like transformations can be reused, good for iterative algorithms, flexible problem processing and slow processing, right? Yes. Spark and Flink, Spig and Spark, Spark advantages over Hadoop MR, and Spark mainly designed for this. And Spark and HANA. HANA is not distributed. Spark and Tej and Spark, right? Spark encoded with multiple languages. Spark can run on multiple distributed clusters. And evaluation of Spark. So real-time usage of PySpark, PySpark features, Python and the Scala, which is more preferred, need for PySpark, PySpark and Apache Spark, right? So this is what introductory session, right? So fine. So once again, right, observe this. Lot of discussion on this PySpark, right? We don't need to write huge codings here. Many inbuilt functionalities available for performing this task, right? Yes, just observe this. PySpark. So PySpark and Scala, PySpark features usage, usage of PySpark, web application, PySpark sessions, context, Spark context, parallelizing, repartitioning, broadcast variables, accumulators, operations over RTD, resilient distributed Spark data objects are called as RTD. RTD actions, inbuilt actions, transformations, RTD persistence, different persistence options, PySpark core computations, right? Fault tolerance model. Fault tolerant model, discussing about the fault tolerant model, different ways of creating this Spark data objects RTD, increasing the number of parallel processing partitions, right? Various groupings and aggregations, group by key, reduce by key, various transformations, various inbuilt actions and transformations, PySpark SQL data frames, right? Creation of data frames, data frame APIs, creating empty data frame from RTD, struct type, struct, row class, column class, select, collect, with column, where, filter, drop duplicates, order by, sort, group by, join, union all, UDF, map, flat map for each, filter, pivot, partition by, aggregate function, window functions, date and timestamp functions, built-in split, concat WS, date format, list, collect, count, rank, so many. PySpark external sources, Spark working with SQL statements, Spark and Hive integration, MySQL integration, working with CSV, working with JSON transformations, narrow and wide transformations, addition of new columns, dropping of columns, renaming columns, adding of new rows, dropping of rows, handling nulls, joins, window function, writing data back to external sources, creation of tables from data frames, stages and tasks, drivers and executor, building Spark applications, pipelines, deploying Spark applications to cluster and tuning, performance tuning, right? And streaming concepts, integration with Kafka and PySpark MLlib, right? So very huge syllabus we'll be discussing in brief, right? So next Saturday and Sunday onwards, we'll be increasing that. We'll go with 2 hours on Saturday, 2 hours on Sunday, right? If 2.5 hours I'll be taking. So next Saturday, the link will be changing, right? So you are supposed to get enrolled into this course, PySpark course, right? So for PySpark core programming, PySpark SQL programming, PySpark MLlib, PySpark streaming, everything is going to be covered of this. The software will be provided to you. So for everyone, whatever configuration you have got, I'll be showing you, and I'll also show you how to work within this Databricks. And a soft copy of the notes I'll be providing every day. Session video session recording you'll be getting. Even if you miss the session, right, you'll be getting the recorded session that day itself, right? Yes. Soft copy of the notes, assignments, tasks, and videos that will be provided to you, right? So a WhatsApp group also will be created for the technical discussion, right? And so next Saturday, a new link will be created, a new WhatsApp group will be created next Saturday, right? And the updates will be given in that. Notes also will be posted in that, right? Yes. So everyone get enrolled into that course, right? So yes. And people basic Hadoop knowledge. For that, I'll be providing videos on HDFS. I'll be providing some videos of this Hive, and I'll provide some videos of Scoop to get the knowledge on those also. And also like basic LFS, Linux, and the HDFS knowledge also. That videos I'll be providing. You can go through next week, right? By the time I start with the practical part. Yes. And also I'll give knowledge on this Python syntaxes. Python all syntaxes like collections, functions, modules, all this I'll be providing the syntaxes before I go. Just I'll take a session on that. Total syntaxes I'll go. It looks like normal English statements. It's not complex to understand, right? Yes. So no need. So Hadoop means only like HDF. See, one HDFS commands are there, right? That if you look, you can understand everything. No need to have much knowledge on this Hadoop. Like PySpark, without any knowledge, you can just go with this. Where this? It's only weekend batch. Which one, right? It's only a weekend batch. Saturday 2 hours, Sunday 2 hours, 4 hours, right? Later I'll make it as 2.5, 5 hours, right? Monday to Friday, if you take 1 hour, 5 hours, that everything will be covered on Saturday and Sunday by taking 2 hours or 2.5 hours, right? Yes. So this was introductory session, right? But next week, right? It will go with longer, bigger sessions, right? Yes.
Sir, how much?
Yeah.
Sir,
What is?
How much experience can we put after this course, sir, in resume?
A typical 3+, 4+ years of experience person, how much knowledge he has to, you will be gaining the same experience, right? So if you see the course content, everything will be discussed in brief with many working examples, right? Fine. So get enrolled. Next week, you will be getting the link to your mail IDs. So get enrolled by paying the fees. The fee structure, everything you can see in the chart panel, right? They have provided the, and just copy it, the fee structure and the payment process and the procedure and the contact details of this online team. Okay. So this is what we'll be discussing from the low level, ground level to the advanced level, right? Step by step, everything we'll be discussing, right? In brief. Yes.
So Vijay, this is for 8 weeks?
Yes, this is for 8 weeks.
2 months.
Yes.
Okay. And what is glue? Glue also made up for, I mean, like it is also a Spark code, like
Which one you're talking?
AWS glue.
No.
You-
So here I'll be giving the knowledge of this at the end of this course. I'll be giving knowledge on this, right? How we can run in on this AWS also, AWS cluster.
Okay.
Like Hadoop EMR cluster will be there, right?
Sir, the classes will only be held on weekends for 8 weekends, right?
Yes, 8 weekends it will be from 4 o'clock to 6:30.
So approximately 16 to 17 classes will be completed.
Yes, 8 weekends. Okay, fine. So I'm stopping for now. We'll continue next Saturday, right? Yes, discussion. Next Saturday, we'll start with the practical part, right? Yes. So next Saturday, I'll be discussing more on this, but from Sunday onwards, we go with the practical part. Saturday, I'll be briefing you about more on this, how the computation of this Spark data objects, how they are going to, how to create them, and different ways of creating them, right? Fine. So thank you all for your time. Thank you. Meet you on next Saturday, right? Yes.
Thank you.
Thank you.